You're scrolling through your phone at 6 a.m. You get a ping and it says, your fridge has been restocked, the flight has been rerouted, you got a taxi waiting when you land, and your tax rebate has already been filed and processed. Sleep tight. No apps, no browser tabs, just a single AI agent seemingly managing your entire life for you whilst you sleep. Today's episode is all about the plumbing that might make this vision a reality. Google calls it the Agent-to-Agent protocol, or A2A for short. Think of it as the shared and common language between your personal agent, your company's HR agent, and even the local council services agent. And if this works, individuals, companies, and entire governments can be ran and collaboration could be managed by AI agents. In today's episode, we're going to explore what this might mean for you and how it might all come together. We're going to dig into the technical underpinnings, as well as the criticisms that have been laid bare against Google for taking an approach like this. This is In the Loop with Jack Horton. I hope you enjoy the show. So the reason I actually wanted to chat about this today is because it really brings together a lot of the different things that I've actually spoken about over the last 8, 9, 10, 12 episodes. I've said this before, but I believe multi-agent systems are the future, and 2025 is the year that multi-agent systems are going to take a massive leap into the spotlight. I covered this, and I think it was episode 6, but as I explained in that episode, there were a lot of challenges to make this really work at scale. You know, it's not easy to have an entire system of AI agents managing lots of things, because there can be absolute chaos or even collapse in an entire system if a series of agents weren't able to coordinate properly, or if there was a really bad actor or a hacker that did things that broke the system. There are also scalability challenges of, you know, how many agents and agent interactions are there going to be if there's hundreds of thousands or millions or billions of agents all at one time. The analogy that comes to mind is what I imagined it must have felt like in the early days of the internet, where people were trying to understand how would millions and millions of people come online on this conceptual thing and work together. I've also discussed some of the challenges with designing user interface for agents. People, if you're not in that technology world, might not really regard that user interface layer as something that is terribly important. You just kind of take it for granted now. And I actually compared in, I think it was episode 3, how Apple really innovated in the early days of the computer and personal computing to make computers accessible to everyone. Well, Google's new protocol is a real swing at trying to solve many of those challenges that I've broken down over the course of this series. So do go back and listen to those episodes. They're super relevant still, and they delve into the challenges of each one of those topics in much more detail than I'm going to do today. Anyway, so why do I think this is going to be a potentially important protocol? The future of AI agents really working at scale is trying to solve the multi-agent question. People often really don't understand what this often means. They think one agent is one agent, or they think multiple agents is a real set of agents and one agent isn't. One agent can be a series of agents, but the way it's packaged up and the interface might only seem like one agent. So all this type of combination of challenge is going to have to be really solved and brought to the mainstream over the next few years, especially when it comes to technology companies. Like Mindset works with technology companies, and we allow and enable them to embed agents into their products really quick. And if I use them as an example, they might use one agent or provide one agent to their customers for searching the internet, another one to run specialized database, say, queries for customers, and another one to do calculations. Each agent is an expert at a thing and has a selection of tools that it can access on demand to do that thing really, really well. And a tool, by the way, is just an integration. So I'll go into this in a bit more detail in a minute. The issue with all of this is that there's no standard. Each agent or system of agents at, say, company A might struggle to work with that agent or series of agents at company B. And there are frameworks out there trying to solve for this, and this is just another one, but there's no open standard yet. As I talked about in the episode discussing MCP, so if you never listened to that, do go back. These protocols are critical for collaboration of lots of people building lots of things, because fragmentation slows down innovation. Every new agent you create actually multiplies the potential complexity. And that's why the world needs a standard protocol to let these different agents talk to each other from different companies. And at a high level, that A2A, so agent-to-agent protocol by Google, is trying to standardize the way AI agents communicate regardless of their underlying implementation. So in essence, it gives a common language to agents and a set of rules to govern interactions at that user interface level. Their goal is to enable interoperability. So any agent can discover and talk to another agent, much like a web browser can talk to any web server via that HTTPS. By solving that communication bottleneck then between agents, they hope to try and enable this world where multi-agent systems work really effectively. Now, you might be thinking, because lots of people have asked it online, is this replacing Model Context Protocol? Which, for those that missed it, it was episode 8. And on that topic, I explained how Model Context Protocol is literally just came out for agents and essentially is a way to enable developers building one agent or agent system or agent product like Mindset to make it easy for those agents to then access other integrations, which are called tools. So, for example, an agent might have a search flights tool from booking.com or a fetch weather tool, let's say, from BBC Weather. Those platforms, Booking.com and BBC Weather, have to make those tool sets available to other agents. And so MCP makes it easy for any company building agents to use that system, and also makes it easy for any company who provides services, products, and data to essentially allow other agents to use their services. And so with this in mind, the agent-to-agent protocol by Google is designed to work really well with MCP. However, MCP doesn't focus on letting agents work together across systems. It's more about letting agents use separate systems like BBC Weather or Booking.com and accessing the data and performing actions on that website. So the A2A, agent-to-agent protocol by Google, you can imagine as a layer above MCP. So let's zoom out a little bit and have a look at the big picture view of agent-to-agent protocols like the one Google just produced. So as an individual, you might really want to plan a holiday. You might say, plan my trip from Manchester, where I live, to New York and then to Hawaii. With agent-to-agent protocols, imagine every person has this personal AI agent as an assistant on their phone or wherever it might be. And so that personal agent can talk to the travel orchestrator agent. That orchestrator agent might talk to the flight agent to find flights, pick a seat and book, and then might speak to a hotel agent to reserve a room, and a car company agent to get a rental car. Now, all of those different agents, those different use cases, will be platforms, companies, and websites in their own right that have also got and published a set of agents. Now, without an agent-to-agent protocol, all this can go wrong. Each agent by each company might have a slightly different setup. Each uses maybe LLMs plus a set of tools, configuration, a set of data. And that orchestrator agent has to merge all of those pieces and make it work. So you see the result as flight confirmed, hotel booked, car rented. But again, all of that can go terribly wrong if they don't work together. So then, how do we make this work? And how does the agent-to-agent protocol, more importantly, try to make this work? So let's dig into that. With that agent-to-agent protocol, each agent just needs to speak the protocol's rules. So they exchange data in something called JSON. And so think about JSON as a simple text format or package format for data. So essentially, JSON is a way of packaging up information that can be read and understood by pretty much every single programming language. So it's a very strict language used to just represent information. You can't actually write programs in JSON, but you can describe data. And then Python, JavaScript, Go, Java, Ruby, Swift, whatever it is, they all understand JSON. So this means agents don't need to agree on the programming language between platforms, websites, systems. They just need to agree on how to structure information when it passes it from one to the other. So Google's not trying to reinvent the basics. By communicating in JSON, it mirrors also how MCP works. So the protocols align really well. And so what we're seeing here in real time is this invention of how the future of technology all comes together. It's like, again, the analogy of the early days of the internet when people were building HTTPS, SMTP. The HTTPS is what you see at the beginning of every URL. These protocols are going to potentially be that important. And I say potentially because what matters with a protocol is adoption. Nobody's getting paid for these. It's a decision that every independent builder, company, thinker, innovator has to work towards and stick to for the greater good of collaboration and success. So I'm going to break down what all the different key components and parts of these protocols are. Another key part of this protocol, other than JSON, is a set of rules for agent-to-agent communication using what's called agent cards. I actually spoke about this in an earlier episode, I think it was episode 3, talking about the importance of agent cards in the future of multi-agent systems, because every message from one agent has to have a set of information as I described. So it has to have a concept of a user, assistant, the role of the agent, and it has to all come together in agent cards. And that all has to be packaged up in JSON. So this means when an agent connects to another agent, it receives that agent card. This card will include a set of information. So it might be the name, might be called the flight agent. It might include a description. So an agent that searches and books flights. It'll include a version, so version 0.0112. It'll include a URL, so the endpoint. And it'll set of skills that an agent has. So these are all the tasks that an agent can do. So it can book flights, it can search for flights. And that card is crucial for discovery. It helps another agent call another agent. So if one agent is requesting for information, it can more easily find the different sets of agents that are going to be able to help it. These cards also provide a level of, let's call it, opinions on how the user interface should be structured for human and agent collaboration. Again, discussed on episode 3. So these cards become really important parts of that user experience because it is the way that a user is updated and informed on what one agent can do over another. It's also what surfaces in the user interface as one agent is looking for another agent and therefore actually is looking through the agent's cards. And it will tell you as a user as you ask a question and it says, I'm going to search agent A, B, D, E, F. And once they've selected one, you can then see what that agent is capable of doing and also what it's going to do to help you. So it's a lot of different stuff they're provided to the world in the form of a protocol. But what does this actually mean for you? So first off, I think this type of approach, whether it's the right one, we'll come on to this, is key for that idea of a personal assistant vision. So you have an agent on a phone, it knows everything that you routinely buy, whether it's, oat milk, cat food, whether you pay for a Sky Sports subscription for football, whatever it might be. And so you can then say, restock the fridge before Friday when I get back from, say, holiday or work. And the agent can ping the supermarket agent, attach your data, check your awards points, and then tell you, boom, purchase, it's cost this much, it'll be delivered at this time, and I've checked your calendar agent, and it doesn't clash with anything. Another really exciting thing is I think it'll reduce bureaucracy over time. Now, governments are going to take a heck of a long time to actually adopt all of these things, because obviously you've got your personal data, your national insurance numbers, or the equivalent in whatever country you live in. So government systems and processes are obviously famously a nightmare, from tax to transport to housing to health. With that agent-to-agent protocol, maybe each department has a series of different agents. So you want to renew your driving license, the license agent validates your identity with the citizen ID agent, which then also checks whether if you've got any unpaid fines with the traffic agent, and maybe then it pulls your eyesight certificate from a health agent. And the result might mean that processing time goes from weeks to minutes. You don't have to go to the counter, very few paper forms, I hope. But what I would say about something like this, although that seems very exciting, this personal assistant agent that speaks to other agents, is that this is very easily a place where things get quite dark. So one of my favorite books is by Kai-Fu Lee. It's called 10 Visions of the Future, 2040. And essentially explores how AI is going to impact people from different cultures from the perspective of a person using short stories, and then provides an analysis afterwards. And one young girl in India met a boy in class that was from another area that was deemed by an AI as more dangerous or from a lower economic class. And so when our family went for insurance, they were rejected because the AI knew that there was a relationship between those two people and deemed these group of people therefore at risk because they knew this group of people. So what I'm describing here is obviously that's a particular scenario, and I'm not saying all of them are going to be bad, but when this thing happens and comes at scale, humans struggle to therefore understand how decisions are being made. And pieces of data are pulled together by an AI agent or a series of agents which equal a checklist. Look at the US health insurance situation where most people might get rejected by AI because it's good for maximizing profit. So these things are very real, and they can and probably will start to happen as these multi-agent systems come to be. Well, let's take it down another level, because I actually think there's a lot of issues with the agent-to-agent protocol by Google. It's definitely not a guaranteed winner. So one of those issues, it's extremely heavy-handed as a protocol. It doesn't just let one agent message another. It tries to solve everything at once. How agents find each other, how they describe what they do, how they handle tasks that take a long time, how they update humans along the way at the user interface level, how they handle retries or errors. So it's a very powerful protocol, but that means that it adds a lot of weight for a developer or a builder such as Mindset. To use that agent-to-agent protocol, developers have to understand the full structure, implement many components, follow lots of rules about formatting, and manage more complex conversational flows. It's not like a plug in and play. And if you compare that to the model context protocol by Anthropic that's been widely adopted and looks like an actual winner here, it became popular because it was so easy to adopt. Developers could literally test it with a few lines of code and see the results really fast, which made it go completely viral online. Whereas agent-to-agent protocol by Google, by contrast, it's like building the whole messaging system before you get to hello world just to actually work in your application. That's why Dharmesh Shah, so the CTO and co-founder of HubSpot, said it's trying to do too much. And he felt that they're trying to gravitate more towards enterprise, actually, rather than an agent-to-agent protocol that allows company A, B, C, D, F agents collaborate better. Another one is actually authentication. So a lot of this specification assumes authentication is assumed. So authentication is, how do I know this person is this person? So inside a firewall or company, hence the CTO and co-founder of HubSpot's view, when you're inside a firewall and a safe space, you can kind of assume everybody's authorized to access this thing. But between separate companies and actors, you can't assume that. It's also complete overkill for, this hacker developer who wants to just spin up a type of agent to do a specific task for it. Also, there's going to be scaling problems with this protocol. So it works really well with a well-defined group of agents in a set of teams across, say, maybe 4 or 5 teams in a company, because these company teams all know each other. They can call each other if something goes wrong. There's only going to be a number of agents possible there. But what happens when there's 10,000 or even 10 million agents? Maybe they're all built by different teams in different companies or scattered across separate countries. Because the current discovery model for agent-to-agent protocol is each agent has a URL, say agent.travelcompany.com. So if you know that URL, you can ask the agent, what can you do? And it will literally reply and say, this is my agent card. So that works really well at a small scale. But what if a new agent joins the network and needs to find 30 others? What if hundreds, thousands, or millions are doing that? And all of them are asking each other questions every minute or second. It's chaos. Agents would literally be pinging each other all the time to see who's available. There's no global index or marketplace or, yellow pages for all these agents. I think Google will probably try to launch that. Other big players will as well. And they'll try and monetize every single inch of it. And also, Google's not managed to bring on Anthropic or OpenAI or Hugging Face or any of the other large language model providers. It's got Salesforce and Accenture. But without the big guns who are providing the models, I don't see how it can be widely adopted. All of these companies have developer ecosystems. So as I say, it's not a clear winner. And you might ask, where does that leave us then? Well, I guess to summarize, agent-to-agent protocol is an attempt to try and set the rules about how agents can communicate in the future. First, it looked like Google were trying to set the rules in a really positive way for separate companies across many countries and locations that have no relationship to each other. But actually, I think they're just trying to go for big enterprise in safe environments in small scale. So although it paints a very clear picture that every person, company, and government is going to have agents representing them, it's just a very heavy protocol. The discovery model isn't built to scale. And right now, it's not accepted by a single big model provider. So I have no idea where this is going to go. We'll be testing it at Mindset in the coming period. But again, it's very heavy, so it's not the thing you're going to jump into over the weekend. But this is an ever-evolving space. Mindset will be experimenting, You'll be the first to hear what I think as we delve into this and what we actually think the future's going to look like. Anyway, that's it for today. Please share this with someone, subscribe to the podcast, hit that bell icon, review it, share it into that Slack channel for people to learn about AI, or share it to a friend. It really helps. I absolutely hate asking, but I've been told I got to do it. Anyway, stay curious and see you next week.